Students, welcome to the new session of Standard 10 Physics, Chapter Electricity, Part 5. Content, Factors Affecting the Resistance, VI Graph. Let us discuss about the factors affecting the resistance. The factors are length of the conductor, area of cross-section of the conductor, nature of the material of the conductor, and temperature of the conductor. Clear? Yes. Dear students, the first one, length of the conductor. So here the first point says that resistance directly proportional to length of the conductor. Here R is called the resistance and L is called the length of the conductor. So the first point says that the resistance of a conductor is directly proportional to its length, which means when the length of a wire is increased, its resistance also increased. And if the length of the wire is reduced, then its resistance also reduced, because these two quantities are directly proportional to each other. And long conductor has more resistance and a short conductor has less resistance. Suppose if we are considering two conductors, the first one is long conductor and the second one is a short one. And here in this case, the long conductor has more resistance, the first case, and the short conductor has less resistance. So simply we can say that resistance of a conductor is directly proportional to length of the conductor. Clear? Yes. The second point, area of cross section of the conductor. Dear students, the second point says that the resistance of a conductor is inversely proportional to the area of cross section. And here in this relation, R is called resistance and A is called the area of cross section of the conductor. So resistance of a conductor is inversely proportional to area of cross section. R inversely proportional to A, which means that when the area of cross section of a wire is doubled, its resistance gets halved. And if the area of cross section of a wire is halved, then its resistance will get doubled, because these two quantities are inversely proportional to each other. In other words, we can say that a thick wire has less resistance and a thin wire has more resistance. It's a very important point. Resistance of a conductor is inversely proportional to the area of cross section of the conductor. It's about the second point. The last 2 points, nature of the material of the conductor and temperature of the conductor. So in this case, the resistance of a conductor depends on the nature of the material of the conductor. Some conductors have low resistance whereas others have high resistance. In a simple way, it depends on the nature of the material. Suppose if you take two similar wires having equal lengths and diameters of copper, metal and nichrome alloy. Nichrome is a alloy and copper is a pure metal. The resistance of nichrome wire is about 60 times more than that of copper wire. So in this case, copper and nichrome, they are different in nature. Nichrome is an alloy and copper is a pure metal. This shows that the resistance of a conductor depends on the nature of the material of the conductor. Because in the case of nichrome, its resistance is about 60 times as compared to the copper wire. And the effect of temperature. The resistance of all pure metals increases on rising the temperature and decreases on lowering the temperature. In the case of pure metals, while increasing the temperature, resistance also increases, and while decreasing the temperature, resistance also get decreased. That is the effect of pure metals. But the resistance of alloys like manganese, constant and nichrome is almost unaffected by the temperature. That is in the case of alloys. But in the case of pure metals, the resistance increases on rising the temperature and decreases on lowering the temperature. Clear? These are the important factors regarding the resistance of a conductor. Clear? Yes. Okay. Next we want to discuss about VI graph. VI graph means potential difference versus current graph. Actually this graph is associated with Ohm's law. Ohm's law means V is equal to IR. Very simply we can say it as V is equal to IR. So in that Ohm's law, V directly proportional to I. So here the potential difference is along x-axis and current is along y-axis. And if you draw a graph between the potential difference and the corresponding current values, the graph obtained will be a straight line like this. And a straight line graph can be obtained only if the two quantities are directly proportional to one another. Right? Yes, since the current potential difference graph is a straight line, we conclude that the current is directly proportional to the potential difference, or potential difference is directly proportional to the current. Clear? Yes. Dear students, after watching the video, you may please go through the textbook and read the textbook very carefully and try to understand the points given in the slides and textbook. Thank you for watching video.